seeing how artificial intelligence will eliminate pure IT majors.
Since the advent of software programming, there have been indispensable programming roles for non-IT majors. This article uses my personal experience to recount this former story and emphatically stress that, in the artificial intelligence era, this trend will only accelerate. The rapid development of artificial intelligence AI, especially large models LLMs, is reshaping the global industrial structure at an unprecedented speed. In this wave of transformation, a discipline long considered a golden ticket for employment, the traditional university pure information technology IT major is facing an existential crisis. Its future difficulty is not an exaggeration. When artificial intelligence becomes a powerful assistant for code generation, pure IT technical ability no longer reigns supreme and is less dominant. The job opportunities and market competitiveness for IT majors are quickly narrowing.
The narrowing career path for IT majors.
IT major education focuses on the fundamental theories of computer science, core algorithms, operating system principles, and data structures. This training cultivates theorists and system architects, but their main application market demand is relatively narrow, almost limited to the theoretical and basic research industries. For IT graduates, the main avenues are restricted to the following areas: teaching and research, deeply researching the frontiers of computer science to lay the foundation for the next generation of technology, or engaging in teaching at universities. These positions require extremely high theoretical depth but are limited in number and disconnected from the broader application market. Moreover, a PhD or higher degree is generally required. Core infrastructure development, participating in operating systems, compilers, underlying chip architectures, and other niche projects that require extreme low-level optimization and theoretical mastery. However, in the profitable and high-demand application development industry, the development space for pure IT majors is compressed to the extreme. A lack of deep understanding of a specific vertical industry makes them feel powerless when solving actual business problems. A graduate in economics with rich financial knowledge can clearly define the requirements for an algorithmic trading system, its risk model, and regulatory compliance. In contrast, a pure IT major, even one proficient in C++ and Python, would need to spend a significant amount of time delving into these complex business logics. Typically, this is almost asking the impossible. Non-IT majors find it easier to handle IT due to the following factors. IT popularization education. From the basic education stage, programming thinking and the use of basic IT tools have become common knowledge. This significantly reduces the reliance on specialized IT technical knowledge. The powerful assistance of artificial intelligence. Artificial intelligence models, represented by Gemini, can generate high-quality, runnable code directly from natural language descriptions. This greatly bridges the technical gap between IT and non-IT majors.
From coders to integrators.
In the artificial intelligence era, the working model of non-IT majors has fundamentally shifted. They are no longer traditional coders but artificial intelligence-enabled integrators. This core competency is reflected in accurate domain querying, the ability to translate complex business requirements into clear, structured, and professional instructions that guide the artificial intelligence to generate the target code. Code understanding and integration. Even without the ability to write code from scratch, non-IT majors can quickly understand the logic of artificial intelligence-generated code, organically combine it, adjust parameters, or integrate it into specific business systems. Artificial intelligence-assisted learning. If they encounter an unfamiliar code block, they can directly ask the artificial intelligence to explain its principles. This is equivalent to having a 24/7 instant response technical mentor. Therefore, for most application-oriented development work, non-IT majors, relying on their core industry insights combined with artificial intelligence as an efficient production tool, can perfectly and efficiently complete tasks, leaving pure IT majors completely defeated in application-level competition. The arrival of the artificial intelligence era signals the end of an era where pure IT technical capability was the core competence. If university IT majors continue to cling to traditional theoretical education and ignore interdisciplinary integration, they will indeed struggle to sustain themselves. The value of future IT talent must shift from mastering technical details to creatively applying technology and solving complex cross-disciplinary problems. Pure IT majors must undergo a profound transformation to embrace the IT plus X model, that is, the integration of cross-disciplinary subjects. For example, IT plus financial engineering, focus on high-frequency trading systems and risk management models. IT plus bioinformatics, focus on gene sequencing algorithms and computational drug discovery. IT plus complex system architecture, focus on the design of ultra-large-scale, high-reliability underlying systems that are difficult for artificial intelligence to replace. Only by proactively combining with domain knowledge and focusing on cutting-edge research and system design that is difficult for artificial intelligence to touch can IT majors in post-secondary education rediscover their irreplaceable core value. In fact, IT projects in any non-IT industry have never strictly required IT majors. IT job postings often list the professional educational background requirements as computer science, mathematics, engineering, regardless of the degree level. All office industries face the risk of being replaced by artificial intelligence, including software studios. However, IT is increasing rather than decreasing, which requires people in non-IT industries to deeply integrate IT. In other words, some non-IT majors must deliberately strengthen their IT skills to fill the job gaps after IT department positions are cut. In this regard, traditional Chinese medicine TCM is a typical example. Excellent TCM practitioners can utilize Qi. This involves the physician injecting their own righteous Qi into the patient's body to expel the patient's pathological evil Qi. The sign of this is that the patient's body will swell up with a large lump after the use of Qi. Precisely because of this, TCM is impossible to be replaced by artificial intelligence, completely impossible.
Artificial intelligence in the traditional Chinese medicine industry.
The reason the TCM industry is difficult to replace with artificial intelligence is primarily due to the complexity of its theoretical system, the personalized nature of the diagnostic and treatment process, and the indispensable humanistic care in medicine. Artificial intelligence has enormous potential in assisting TCM, but complete replacement is impossible. Artificial intelligence excels at processing standardized, structured data, while TCM theory and practice have a unique individuality that is difficult to quantify simply. The core of TCM is Bian-Zheng-Lunzi syndrome differentiation and treatment, which emphasizes individualized treatment. One disease may have different syndromes, and the same syndrome may manifest differently in various individuals. Artificial intelligence models tend to oversimplify the process of syndrome differentiation and cannot fully reflect the complex logic of TCM. The experience, intuition, and insight of senior TCM experts are often tacit knowledge that is difficult to express in words or data. Existing artificial intelligence technology still has limitations in understanding and simulating this complex expert decision-making process. The data types in TCM's Wang, when, key inspection, listening, smelling, inquiry, and palpation are diverse, such as tongue presentation, pulse condition, voice, smell, and medical history descriptions. The data structure is complex and lacks unified standardization and normalization. For example, artificial intelligence can collect pulse data through sensors, but fully simulating the subtle perception of depth, strength, or weakness when a human hand takes the pulse is almost unbelievable. Training excellent artificial intelligence models requires large-scale, high-quality clinical annotated data. Currently, the underlying textual data encompassing ancient texts and medicinal materials is relatively rich, but experimental and clinical data are comparatively lacking. These restrict the practical implementation of artificial intelligence models. Many artificial intelligence models based on machine learning and deep learning have extremely complex and opaque operating mechanisms, exhibiting black box characteristics. When a model gives a diagnosis or treatment recommendation, physicians find it difficult to understand its reasoning process and basis for judgment, which lowers the clinical doctor's trust in the model. The essence of medicine is not just curing the disease but also curing the mind. In TCM's Wang, when, key, especially when inquiry, there is a human interaction, communication, and emotional support between the doctor and patient that is crucial for recovery. This humanistic care, which transcends medical technology, is beyond the capacity of artificial intelligence. If artificial intelligence replaces doctors in diagnosis and treatment, the attribution of responsibility is difficult to define in the event of misdiagnosis or treatment failure. Existing regulatory laws such as the requirement that prescriptions must be issued by the attending physician themselves, strictly prohibiting the use of artificial intelligence to automatically generate prescriptions typically require medical personnel to be real name authenticated and possess professional qualifications. Artificial intelligence software cannot impersonate or replace the physician in providing diagnostic and treatment services.
The independent IT excellence of non-IT industries.
The popularity of IT covers aspects of human society, but the specific manifestations are diverse. For instance, computer-aided design CAD software development in the construction and mechanical manufacturing industries is a godlike existence. I have some stories about this. A long time ago, while I was studying abroad in Germany as part of an inter-university cooperation project, I worked at a CAD software development company in the technology center of the University of Bochum. At that time, there were about 20 programmers, with only 3 being IT majors. The rest were architecture and mechanical majors. According to project division, the team was split into 6 project groups. 5 of the group leaders came from architecture or mechanical backgrounds. Only 1 project leader was an IT major, and this group was a support, not a primary, project group. The company's technical director was an IT expert with an architectural background. Once, he attended a Microsoft European conference and, upon his return, reported that the future programming hotspot was the newly developed MFC Microsoft Foundation class. Everyone seemed indifferent after listening. I recognized this as a once-in-a-lifetime opportunity to stand out, so I began to intensively study it in my spare time. At that time, I was in charge of the company's dialog boxes, all static products used to represent various steel shapes, such as I-beams, angle steel, channel steel, and even railway tracks. A total of 4,500 types were cataloged. This resulted in 4,500 dialog boxes. Perhaps some predecessors were not very dedicated, as some dialog boxes showed obvious signs of shoddy work. So, I had a sudden idea, to consolidate all dialog boxes into a single, parameterized dynamic dialog box based on MFC. The company was thrilled by this suggestion and immediately convened the heads of all project groups for an on-site demonstration, deciding to regroup every Friday afternoon to observe the progress. Logically, this kind of frontier technology exploration work should have been the responsibility of the IT majors. Unfortunately, they neither had the willingness to face the challenge, nor did the company have confidence in them. After all, this involved specialized knowledge in architecture and mechanics, as well as practical CAD operation experience. I was already a structural engineer and had extremely rich experience in using multiple CAD brands. Crucially, I had achieved a small feat. For example, in the Beden Atlas, a concrete Bible jointly compiled by 4 top German structural masters, my supervisor was one of them. All the 3-dimensional illustrations for the thin shell structures were created by me using 2D CAD because 3D CAD was not yet available then. A German colleague once exclaimed loudly in a whisper, "How could he have created a 3D drawing using 2D CAD?" In fact, those 3D illustrations were static and could not change viewing angles. The key to their creation lay in being skilled at using construction lines. For example, to vertically join a small circular pipe to a large circular pipe, the method is: draw a T-shaped central axis for the pipes. Along the horizontal direction of the T, draw the large circular pipe as densely arranged, equally sized rings. Along the vertical direction of the T, draw the small circular pipe as densely arranged clusters of straight lines normal to the rings. Cut off the part of the small circular pipe that intersects and inserts into the large circular pipe. Connect all the endpoints with a line. The task is successfully completed. In those days, CAD training for drafters was budgeted for half a year. Some companies couldn't master CAD and gave up. CAD software development was even more outrageous. Newly hired programmers had to be trained in CAD first, and then in CAD programming. Those who couldn't learn were eliminated midway. In reality, neither CAD nor programming has much to do with professional education. It has a lot to do with personal talent. Just like vocal music, a person who is naturally tone deaf can never become a singer, no matter how much they are trained. In that era, it was impossible to hire suitable talent. Everyone was trained after joining the company. Getting back to the main point, the result of that dynamic dialog box far exceeded the original promise. It not only achieved dynamic display but also dynamic editing. For example, if the standard thickness of angle steel is 6.2 millimeters and it needs to be changed to 7.6 millimeters, you can double-click the dimension number with the mouse to activate it as an edit box in place. After modifying the number with the keyboard and pressing enter, both the dimension number and the graphic update accordingly. Crucially, the graphics outline, shadow, and dimension line format all comply with professional standards. If this task were handed over to a pure IT major, they would need to be paired with an architecture mechanical major for collaboration. If so, firstly, it would be difficult to achieve the ultimate quality. Secondly, the two might also come into conflict. This was a lesson learned, as it had happened in this company before, with cutting-edge IT skills, who would look back and return to their old profession. Therefore, after immigrating to Canada, I have been working in IT. To improve myself in my spare time, I self-studied more advanced technologies. The practical projects I worked on increasingly resembled CAD. Eventually, I simply initiated a project and followed that path to the end. Thus, the first version of the MFC-based HiwayCAD was created. This project also won the first prize in the third session of China's national-level Chunhui Cup competition.
The driving force of artificial intelligence.
For software programming by non-IT majors, the support of artificial intelligence is clearly more advantageous for graduates of their respective majors and more detrimental to pure IT graduates. Therefore, post-secondary education in the artificial intelligence era should reduce the proportion of pure IT majors while increasing the proportion of programming in non-IT majors. It should even open up new specializations. For instance, the mechanical engineering major could establish a specialization in mechanical computing. In fact, IT in the artificial intelligence era should not be encouraged to be an independent major but should be popularized across various disciplines. It's like the current situation in China where almost everyone knows English and everyone has a driver's license. After all, IT is the only profession where one can be self-taught. Especially for graduating students heading to university, even if they are passionate about pursuing an IT career, they should generally not be rashly encouraged to directly apply for an IT major, but rather study a science or engineering discipline. Then, they should rely on the belief of self-learning to achieve their IT dream. When the dream comes true, they will become cross-disciplinary dual majors, elevating from students to scholars, and will undoubtedly be unrivaled, contributing more to society than a mediocre Ph.D.